Hello students, welcome to EPG Pathshala. I am Dr. R.K. Verma, former Chief Scientist from CSIR NISCARE, which was earlier known as INSDOC. Today we are going to talk on module entitled Literature Search from Paper Information Sources, Systems and Services. The purpose of this talk is to make you understand various aspects of literature search like its objectives, need, search strategy, Boolean logic, and about information industry itself. The major objectives are to learn to search professional online databases and the web efficiency and effectively emphasizing their use as part of reference service in libraries and information centers, and to become acquainted with the characteristics of bibliographic and non-bibliographic databases from a professional searcher's point of view. Then to learn the basics of searching the most widely used professional online information system in college, public and school libraries. Then to understand the role and functions of the search intermediary and search instructor. And finally the research to raise awareness of the deficiencies in the expensive professional online information systems. Need for literature search. As literature search involved search and evaluation of the available literature in a given subject area, it is needed due to the points like literature search is a core part of the academic communication process. It connects to a researcher's work to widely scholarly knowledge as it demonstrates understanding and puts any research that has been done in a wider context. Then it identifies potential issues with the work a researcher plans to do. It also helps to avoid unnecessary duplication in research work and to understand that the work to be undertaken is relevant, worth doing, and might add to the body of knowledge. Fundamentals of online information systems. Online information retrieval or online searching is the acquisition of information from a distant computer via a terminal or PC involving an interactive dialogue between inquirer and computer. Information retrieval is now seen as an interactive or social activity with the various situations and aspects of the user influencing overall system performance. A reference can be seen from Wang and Forgino in 2006 in this regard. Lancaster actually explained the concept of online information retrieval as that are often unfamiliar or confusing to his readers, including Boolean logic, file structures, evaluation criteria, and vocabulary control. Information industry. The information industry was a world of secondary publishers of indexes and abstracts who leased their bibliographic databases to third-party vendors or large library systems. The bibliographic databases and early search systems served as pointers to primary publications that remained in print containers such as printed journals. Today, secondary publishers and third-party vendors both still exist, but primary publishers are also electronic publishers, and the lines between the three are less sharply drawn. Bibliographic databases pointed to printed content. Today's content is most often completely in digital form. Linking through technologies such as OpenURL and cooperative initiatives such as Crossref draws all parties together for a unified search experience. Here reference is given by the author Grog in 2006. Major scientific primary publishers such as Elsevier, Wiley, Springer, etc. all have their own search and retrieval platforms in addition to participating in the search and retrieval system. Now let me explain how to develop the search strategy. The development of the search strategy includes conceptual formulation of query, translation of conceptual formulation into the language of the keywords, descriptors or facets, identification of synonyms and associated terms, etc. The concept of facet analysis, that is PMEST, given by Ranganathan, as well as the concept of specific subject can be used as an effective tool for designing a query. After this, it is important to select the information domain to be searched, like the opaque of a library, database, or likewise, depending upon requirements. The search string or query is the combination of terms, actually keywords or descriptors, which represent the information. As search strings contain vocabulary, the linguistic features and their implications on the search and retrieval of information have to be analyzed. Here there are three aspects, namely syntactic, semantic and Boolean operators, which are to be understood. Syntax of a search string deals with the kind of formula or connecting symbols through which keywords or terms are connected to represent the concept to be searched by the search engines. The semantics in a search string deals with the meaning of the string in the context of the required information and the interpretation by the search engine. The Boolean operators are explained and you will see in the slide. Formulating the search strategy. These are the steps which are used for search strategy. Firstly, use the databases intensively and critically. Expect frustration. Persevere means don't leave it and follow it up. Consult database help files, readings and lecture slides early and often. Work on your own, then reach consensus with your group on the best solutions. Next, keep a digital diary of your search steps, rationale and results. Screenshots are mandatory. Back up your files. Be prepared to demonstrate your results in class. Don't procrastinate. There is no excuses. Free write and plagiarize. The time required to develop an optimal search strategy is often underestimated. Searching is actually a very complex and time-consuming process. Planning the search. Regardless of the search tool being used, the development of an effective search strategy is essential. If one hopes to obtain satisfactory results, a simplified generic search strategy might consist of the following steps: formulation of the research question and its scope, then identification of important concepts within the question, identification of search terms to describe those concepts, consideration of synonyms and variations of those terms, and the preparation of the search logic. Planning the search. This strategy should be applied to a search of any electronic information tool, including library catalogs, CD-ROM, and online databases. However, a well-planned search strategy is of especially great importance when the database under consideration is one as large and amorphous as the World Wide Web. Another factor that underscores the need for effective web search strategy is the fact that most search engines index every word of a document. This method of indexing tends to greatly increase the number of results retrieved, while decreasing the relevance of those results because of the increased likelihood of words being found in an inappropriate context. When selecting a search engine, one factor to consider is whether it allows the searcher to specify which part or parts of the document to search. For example, URL, title, or first heading, or whether it simply searches the entire document by default. The most productive searches are those where the information seeker has spent time working out a search strategy before going online. This strategy is a prerequisite for anyone attempting exhaustive searching, such as those embarking on research, and recommended practice for any user wishing to conduct an efficient search and avoid frustration caused by low retrieval. In situations where connect time is charged for a search strategy, it is essential to prevent escalating costs. Searcher and user should work out specific information needs and identify the different major concepts and alternatives. For example, the topic inorganic fertilizer has two main concepts, that is inorganic fertilizers and soil fertilization. Put the ideas on paper in natural language. Examine each concept to find as many synonyms and terms as one can think of, and group the related items together to provide the basis of a structure for searching. For example, inorganic fertilizers, then fertilization, soil fertilizers, fertilized, or under fertilization you have plants, fertilizers, and producing factories. Consider the levels, the amount of information required, any limitations by date, language, etc., and add these qualifications to the structure. Controlled vocabularies and thesauri. Controlled vocabularies and thesauri include lists of keywords which are authorized items or descriptors used to organize subjects in a defined and standardized methodology to describe the contents of a work. There are multiple terms or synonyms applicable to a subject, and controlled vocabularies and thesauri serve as a means of standardizing subjects into keywords that represent the concepts of that subject. This reduces ambiguity among subjects with multiple terms or synonyms and ensures that most, if not all, works on the same topic will be indexed using the same keyword. Use of controlled vocabularies and thesauri enhances standardization of how works are described and indexed, promotes consistency of such results, and allows for replication of search results using the same query. A controlled vocabulary or thesaurus often includes a definition, and some include scope notes to provide context for the keyword, or as well as qualifiers or subheadings to allow for more precise searching. Some controlled vocabularies and thesauri offer additional keywords for searching in order to refine a search strategy. Most major databases utilize controlled vocabularies and thesauri for indexing of their works, with some using multiple controlled vocabularies and thesauri. The development of the search strategy includes conceptual formulation of query, translation of conceptual formulation into the language of keywords, descriptors or facets, identification of synonyms, and associated terms, etc. The concept of facet analysis, that is PMEST, given by Ranganathan, as well as the concept of specific subject, can be used as an effective tool for designing a query. After this, it's important to select the information domain to be searched, like the opaque of a library database, or likewise depending upon requirements. The search string or query is the combination of terms, keywords or descriptors which represent the information. As such strings contain vocabulary, the linguistic features and their implications on the search and retrieval of information have to be analyzed. Here, three aspects, namely syntactic, semantic, and Boolean operators, are to be understood. Syntactics of a search string deals with the kind of formula or connecting symbols through which keywords or terms are connected to represent the concept of which is to be searched by the search engines. The semantics in a search string deals with the meaning of the string in the context of the required information and the interpretation by the search engine. The Boolean operators are explained in the subsequent section. Boolean logic. Boolean logic is the term used to describe certain logical operations that are used to combine such terms in many databases. The basic Boolean operators are represented by the words and, are, and not. Boolean operators are simple words and, are, and not used as conjunctions to combine or exclude keywords in a search. These are used to connect and define the relationship between the search terms, thus resulting in more focused and productive results. These three terms are widely accepted by the designers of the search engines. They have well-defined meaning while used as operators in information search. The three operators of Boolean logic are the logical sum, or logical product, and logical difference, not. All the information retrieval systems allow the users to express their queries by using these operators. Let us now understand the implications of these three operators. Boolean logic AND. If you need to pose a more specific query, use the Boolean operator AND, which limits results to those items that contain both or all of the search terms in your query. Again, using the two words from the example above, the search query would retrieve only those items containing both words in the same item, that is, for example, inorganic fertilizers and soil fertilization. This search query would return a much smaller set of hits, and the items would be more applicable to the field of inorganic fertilizers. To demonstrate the difference between the OR and operator, run the two strategies above using internet. For example, the search query inorganic fertilizers or soil fertilization returns over 31,000 items, while the query inorganic fertilizer and soil fertilization returns only 176 items. The OR operator is useful for the first phases of a search, when one is not exactly sure what information is available on the topic or what words are used to categorize it. When used between two words, the OR operator instructs the search tool to retrieve any record containing either of the words. For instance, the search query would retrieve items containing either the word fertilizers or the term fertilization, to be used as inorganic fertilizers or soil fertilization. Under Boolean logic, one searcher views the types of items containing either word. One might want to narrow the search by dropping one term and confining the search to the other. For instance, one might find that the records indexed under the term fertilizers are more relevant to the research question than those indexed under fertilization. Or, as in the example below, one might find that the term items related to the specific field of soil fertilization must contain both words, not simply either one, because OR is the Boolean operator that returns the most hits items, that is, item meeting the search criteria. Search queries containing OR are very broad and sometimes return items that are not relevant. The last of the three most common Boolean operators is the word not. The not operator is used to eliminate records containing a particular word or combination of words from your search results. For instance, if one is performing a general search on soil fertilization, one might wish to exclude items dealing with the very specific discipline of fertilizers production. To make this exclusion, one would construct the search query as fertilizers not organic. This search would return all items containing the word fertilizers except for those that also contain the word organic. Another example for Boolean operators searching is provided in the following figure. You can see first extreme left figure says cats and dogs as the overlapping circle tells retrieves items that contain both terms. Then cats or dogs retrieves items that contain either term. And the rightmost figure shows not use of not Boolean operator, that is cats not dogs. It only retrieves items that contain only one item. Search process includes certain steps. First of all is choosing and developing a topic, then designing the search, then carrying out your search and evaluating the results, then handling the products of your search. Then how to choose and develop a topic. The first stage of any information search is to know what one is looking for. As for behind any research search, there should be a good, well-defined topic. But to know whether or not the topic is a good one, there are some general rules to follow. The rules are: number one, if possible, choose a topic that interests you. There are fewer things more difficult than trying to write about a topic in which you have little or no interest. Number two, be sure your topic is neither too broad nor too narrow for the assignment you have been given. Check available time you have and the requirements to see how much you are expected to write about the topic. Then choosing a topic about which there is likely to be some information available in the library and or on the internet. You should do some preliminary checking for potential sources before you decide on your topic. Next is, if you are selecting your own topic rather than the one required to be searched by a user, make sure your topic is feasible before you start your research. Now, how to design the search actually? There are a number of methods for finding a search topic. Depending on the available time and scope of the topic, the search can be designed. The searcher should have knowledge of data structure adopted by the database or the information system that stores data before executing a search. The system-based search engines are designed to search information in a database according to its architecture. Then, depending upon the need and purpose of the search, expertise of the searcher, the search may be conducted using the features of the search engines. Hence, a searcher should know the types of search and implications to get effective output. Then, the process of carrying out search and evaluating the results. In this process, we use the various search tools which are available. The quantity of published scientific material continues to grow exponentially, as you know. Fortunately, there are tools like secondary sources, encyclopedias and dictionaries, reviews, databases, abstracts and indexes, which help you to search for information on a given topic. Evaluate these references you find for relevance to your task. If necessary, modify the search strategy. Then, how to handle the products of your search. Having found interesting references, your next task is to make good use of them. This involves obtaining the corresponding full text documents, critical examination of the material, organization of the information, possibly in some form of personal database, and incorporating into your personal frame of knowledge. This provides the starting point for further work. Under the subject searching, it is necessary to use the exact subject headings adopted by the database. There are two ways. Number one, keying in search terms and selecting or clicking one or more subject terms available in the database. Constructing suitable complex keywords, search statements is crucial to developing searching expertise. Two major steps in composing an effective complex keyword search statement includes constructing search terms and using appropriate search operators to combine the search terms to form a search statement. Future trends. Lancaster and Fian in 1973 made 14 predictions of what the future of online systems might be. They recognized the danger of predicting the future and that we may be just beginning to scratch the surface on the possibilities of applying technological advances to problems of information transfer. Danger aside, they were remarkably persistent in their predictions, which included a great increase in the number of information services that can be accessed from around the world, including large general purpose systems and systems for specialized subjects. Specialized systems will be more user-oriented, easily accessible, and will require comparatively little effort to use. Systems will exploit the interactive, heuristic, and browsing powers of the online computer more fully for practitioners in a field rather than information professionals. They should be oriented to natural language rather than controlled vocabularies. Vocabulary search aids at the time of searching will be incorporated, bringing together synonyms and semantically related terms. Computer-aided instruction should be incorporated into systems. Systems should be capable of being searched by techniques other than formal Boolean expressions, including English language input, relevance ranking, fractional retrieval, partial match. Then online retrieval systems must certainly permit the ranking of output. Future online systems must require less effort to use. They should adapt to the user rather than expecting the user to adapt to them. Online systems and the equipment to use them must be more widely accessible. Systems will provide online support to personal files. Ultimately, online systems must interface with systems capable of retrieving and displaying complete text. Informal channels of communication will remain important, and new communications technologies will facilitate the transfer of information among scientists. And online systems will interface with other systems such as statistical packages, text editing, programs, etc. What are the obstacles in online searching? Many databases available, but each covers different types of information and subject areas. Each has its own unique organization in terms of subject headings, indexing, limits are all different. Conference proceedings, many access points available to locate conference proceedings, databases and websites. Database backup, unavailability time. Many databases are only on charge basis, too costly. Now let us conclude what we have discussed. With great advances in hardware, software and telecommunications is allowing growth of online systems into much more than the system described by Lancaster in 1973. End users not only have their hands on today's systems, their needs and experiences are driving developments and the future of the information creation and retrieval as never before. Now, most of the users try to get the full text on their own from search engine to sites and from the author themselves. Only when there is a demand, online searching is done with the help of publishers, DBs and dialog STN as per the user's request. So students, let us see what we have learned from this module. In this module, we have discussed about the various aspects of literature search, such as its needs, search strategy, planning search, search process itself, subject searching and some of the future trends also. Thank you.